This conference will now be recorded.
Beautiful. Now we are good to go. Guys, as the topic says, this is virtual extensible local area network technology. This technology has replaced Cisco's technology, which was there up till version 2.1. The name of the Cisco's technology is OTV, Overlay Transport Virtualization. Why telling you this particular name? Because the very first letter, which is overlay, this letter in itself is very much intuitive and applicable with regards to this particular technology only. What is this technology? Why this technology? Why not OTV? Because this technology, point number one, this is industry standard, unlike Cisco proprietary technology like OTV was. Officially, Cisco has removed to OTV, overlay transport virtualization, from our CCIE version 3.0 blueprint and has given importance to this particular technology. Understanding this technology is also very important in terms of understanding the next flagship technology called Cisco ACI, application-centric infrastructure. This technology gives us a brief introduction of the topology ACI works in, and indeed VXLAN as a control plane protocol runs in ACI as well. So quite an important technology for us to understand. And in this particular session, we are going to learn about the basics of the technology, and thence on, we will be looking at into the deep dive lab. And I just want to tell you a bonus of learning this technology. Once you are done, then I'm planning to extend this technology by using DCNM, also Data Center Network Manager. This is a graphical user interface tool to configure, monitor our different Cisco Nexus devices. So this is in pipeline, in production, the DCNM way of configuring VXLAN, and that too not one single site, but multi-site VXLAN. Right. So, but first of all, let's get started. The topics which we are going to cover in this particular technology, first of all, we will understand the topology. Understanding VXLAN topology is important from the point of view of understanding ACI as well. We will compare the and differentiate underlay versus overlay. We will look at into what overlay based data centers are and what constitute overlay data center. We will look at into the evolution of VXLAN, the terminologies used in VXLAN, what are various VXLAN deployment mode. And guys, let me tell you, this VXLAN today is marketed as Vxlan MPBGP EVPN. We don't call it, in case if someone says, do you know VXLAN? Then his question is, do you know MPBGP EVPN mode of VXLAN? So understanding this is very important. And you know what? Our 80% focus will be on this particular deployment mode of VXLAN, and our lab which we will do will be based on MPBGP EVPN mode of VXLAN. So, well, this is the flagship deployment of our VXLAN. But this doesn't mean that we will not be looking at into its predecessors. Yes, anyways. So, and finally, the lab will be on VXLAN MPBGP EVPN deployment. So, something is imperative over here from your side. Before we come over to this particular point, I would request you to get a handsome revision and understanding of BGP, Border Gateway Protocol. And if you can add up the multi-protocol concept of BGP, please do that as well. try to understand what is multi-protocol BGP. This is just a prerequisite to understand and do this particular lab. And well, in case if you need revision, we have got a basic to advanced book on MPBGP that is available in our LMS portal. You guys, once enrolled, you guys can download that book. And definitely, and those who are already enrolled, they can download the book on MPBGP. Pretty important to brush up your knowledge about the BGP. What is BGP? How do we configure BGP? What is neighbor relationship? What is established state, etc. Just the basic of BGP. Rest portion we will cover in terms of configuring BGP with regards to an address family called eVPN, because eVPN is one of the address family in MPBGP. With this, let's get started. First of all, let us understand the topology VXLAN is based on. VXLAN is based on a network topology known as clause network topology. This is after the name of a gentleman, Charles Clause, who formalized this technology in the year 1953. However, the topology was first of all designed in the year 1938 by Edson Irvin. And then this technology, a formalized technology, was used by Bell Telephone Company. To connect its telephone switches, right? And this is a topology wherein by the virtue of its connectivity, there is no scope of having any layer 2 loop. Why? Because in this particular topology, having two-tier architecture, 1 and 2, the upper layer devices, which are known as spine switches, the lower layer devices, which are known as, these are known as leaf, these are known as spine, they are connected just north to south. Dear friends, there is no east to west connectivity, or in other words, there is no lateral connectivity between the spine switches. Sorry, they are not directly connected. The leaf switches, sorry, they are not directly connected. This avoids any scope of layer 2 loop, and thus the layer 2 loop avoidance mechanism, spanning tree protocol, is not required. I will not say not available. Spanning tree protocol is there, available, but is not required. I think probably there is a question. Any moment, guys, if you feel you have a query question, please feel absolutely free to ask the question in between.
So here, like in OTV, we have. I think we don't have a concept of the STP, right? Because in this between the spine and leaf, we don't use the STP, and we have another concept like conversational or conservational forwarding or traditional forwarding, right? So here is the same
conversational
concept.
learning.
Yeah.
Absolutely right, dear
Mm-hmm.
friend Akash.
Okay.
In
Mm-hmm.
this case, we do have availability of spanning tree protocol on our switches, but by the virtue of the topology, the connectivity, the spanning tree protocol is not required, because spanning tree protocol is required when the switches, they do form a loop like this. You don't need spanning tree protocol if you don't connect these two switches together, because they are not forming a complete loop or a circle, right? So VXLAN is based on non-availability or non-usage of spanning tree protocol, and probably you guys all know that spanning tree protocol was developed by Radia Perlman in the year 90. It was developed in early 80s, right? And the this particular topology was invented in 1938. So that time there was nothing called spanning tree protocol. Point, the very first point for us. Okay. Now, as a matter of fact, we should now know what is the difference between underlay and overlay. Guys, this VXLAN is an overlay technology. And whenever a terminology called overlay comes into picture, just think that this is a tunneling mechanism. First time we heard of tunneling in case of VPN, virtual private network. Between two endpoints, if we want to secure our traffic, what we do create is something called tunnel. This VXLAN in the same way is a tunneling technology, but any tunneling technology needs a connectivity, and that connectivity is nothing but that connectivity is called underlay. The connectivity which you are seeing over here between your leaf and the spine switches, north to south connectivity, that connectivity and the physical as well as the layer 3 connectivity is known as underlay. But VXLAN runs on top of the underlay. So let us understand some of the terminologies, common terminologies which we use in case of underlay and then in case of overlay, and then we can establish comparison between them. In case of underlay, we have layer 3 interface pairing between leaf and the spine switches. That means over here we require layer 3 address and here we require layer 3 address. This means we do have layer 3 interfaces and IP addresses are configured. The leaf switches are known as edge devices, and they are the one which are connected to the access devices, that is end devices. You can call those that segment where they are connected as a LAN segment. Devices may be the virtual devices or they may be physical devices. Now this is something important. In case if we are not aware of the virtual device concept, then guys, you have to wait for the completion of this topic called VXLAN, and then in the topic called ACI, application centric infrastructure, we will be talking about network virtualization, how this virtual networking is done, what are virtual devices, etc. So if you can note down something which I'm going to definitely zoom to show, this is called hypervisor and here this is called bare metal. The terminologies which we talk about, so we are establishing difference between hypervisor and bare metal. Bare metal means a single machine, physical machine, where no server virtualization concept is being implemented. Guys, probably this may be a new terminology for you, but very much widely used in the industry now. Bare metal refers to a physical server having one single operating system and only one single machine running. In case of the virtual server, wherever you happen to see hypervisor concept, you can see over here multiple virtual machines are running. So this is indeed not a problem. Well, these are terminologies with regards to underlay. Now, let us move over to overlay. Overlay is established on top of the underlay. Once underlay network is available, then we create tunnels, and these tunnels are supposed to be created between these devices. The tunnels do not need a connectivity, that is a virtual connectivity between the leaf and the spine. Of course, indeed, there is a layer 3 underlay connectivity, but it provides a direct connectivity between the edge devices. Here, in case of overlay in VXLAN, these edge devices are no more called as edge devices, but they are called tunnel endpoints. And since they represent a virtual, we call them as VTAP. You know what? While telling you about the introduction of VXLAN, I am also covering the terminologies to be used in VXLAN. All right, but now I need to tell you various overlay mechanisms or overlay types. And in order to tell you what are different overlay types, number one, network overlay, number two, host overlay, and number three, hybrid overlay. I need to remove my slide from the slide share mode and zoom it up to show you something more. But before it, if you look at into the network overlay, so we have got our edge device now, which is known as VTAP device, VTAP, VXLAN, I'm sorry, VXLAN tunnel and point device. Now the overlay, that is a tunnel, is being formed between one VTAP to other VTAP. But the tunnels are being formed. These VTAP devices, physically, they are the physical devices or physical switches. Point number one. Now I need to remove it from slide share mode. Let me escape, discard, and I need to zoom it. Guys, now let us look at into the host overlay. I am going to zoom it so that you can read what is written over here. Yeah. So our host overlay, trying to bring it more closer to you. Yes, here. Because the slide share mode was not sufficient. Now, our host overlay is being configured not on those physical switches which used to be called as VTAP devices. Our host overlay is configured on the virtual VTAP devices. You know what does this mean? This means the VTAP which you do see over here written, this VTAP is no more a physical, this is a virtual switch. So in case if you create your overlays in between two or more than two different virtual switches, that particular overlay concept is known as host overlay. Guys, probably if you have heard of VMware, and in VMware there is a network virtualization technology known as NSX, because VMware do not provide you any physical switch. VMware says you give me bare metal and we will provide you complete network virtualization on them, even the VXLAN. So in case if using VMware technology, you are configuring the VXLAN, this means you are configuring host overlays and not network overlays. Well, this is not part of our curriculum. Point to be noted, host overlay. And I will be more comfortable to tell you explain you this once we are done with the concept of network virtualization in application centric infrastructure, because in case of application centric infrastructure we learn how to create a virtual distributed switch and how this virtual distributed switch works. All right, so let me zoom it out and come back to my slide share mode. Back onto slide share mode to look at into what is hybrid overlay. In case of an hybrid overlay, we need to appreciate a mixture of network plus host overlay, wherein on the one side you have a virtual distributed switch, and on the other end you have VTAP configured on your physical switch. So when you have both the VTAPs, one on the physical switch, one on a virtual switch configured, and they are creating overlay, then that overlay is known as hybrid overlay. Overlay means overlay is nothing but it is a tunnel. Any moment, if you have any question in between, guys, feel absolutely free, because understanding VXLAN and doing the lab on VXLAN is very important, and for that the most important is understanding the concept. Then VXLAN will become very easy. All right, so overlay we have discussed, 3 different types of overlay: network, host, and hybrid. In our lab we will be configuring our network overlay. If you are undergoing VMware NSX training, then it is host overlay that they do configure. If you are undergoing a real production environment, then you will happen to see a implementation of hybrid overlay. All right, now after this let us look at into the overlay terminologies. As we have seen our underlay terminologies, now let us see overlay terminologies. Now these devices called VXLAN tunnel endpoints, in case of VXLAN they are the physical devices, can be virtual devices. In case of underlay we used to call them as edge devices, but now these physical switches are known as VTAP. We have just seen that these switches can be physical or virtual switches, but we are not going to talk about the concept of virtual distributed switch to understand VTAP. So the devices in underlay known as edge devices, now they are called as VXLAN tunnel endpoints. Point number 1. The segment which used to be known as LAN segment, we will call it as VXLAN segment now. And of course, the virtual server and physical server. And there is nothing to be looked at into the connectivity between leaf and spine, but this doesn't mean that this is not required. This connectivity, guys, for the purpose of VXLAN configuration is a prerequisite, but once we come over to VXLAN configuration, we do not look at into this. Yes, but when it comes to MTU and other parameters to be configured, this connectivity definitely needs a prerequisite requirement. All right, so over here you can see with regards to your AND devices, the devices can be running on hypervisor or they can be the bare metal host devices. Bare metal means a single machine having a single operating system. Hypervisor means multiple machines having their individual operating system in case if it is VMware based. If it is some other vendor based like Kubernetes, if it's a concept of Dockers and containers, then it is single operating system but multiple applications. That is the concept we can discuss, but later on. So as if I was saying, overlay is a tunneling mechanism wherein we do create the tunnels in between the VTAP devices. All right, with this brief introduction, let us now understand the VXLAN. So number one point which is clear from the introduction is the topology, the connectivity. You have upper layer devices and these devices are known as your spine switches. You have a lower layer and these devices are known as your leaf switches. This is always a north to south connectivity. No scope for having our east to west connectivity. Apologies, sorry. No lateral connectivity between either between the spine switches or between the leaf switches. Point number one. This is nothing but this is called L2 in L3. L3 is nothing but it is underlay and VXLAN provides us L2 connectivity. We also call it that this is Ethernet in UDP and I should say IP. So that means the Ethernet that layer 2 802.1q which is VLAN is removed and Ethernet packet or the frame is encapsulated by UDP header followed by an IP header. We will see what is the significance of UDP and what IP does. All overlays are encapsulation, and this is very much similar to overlay transport virtualization but more advanced than that of OTV. To have more number of L2 segments via multi-tenant. Now this is another buzzword in today's world, multi-tenancy.
Gee, I forgot OTV. OTV. OTV.
OTV
So,
stands for Overlay Transport Virtualization, which is Cisco's overlay technology, available only on Cisco Nexus switches. Now, in our CCI data center version 3.0, this is removed from the blueprint. Otherwise, earlier we used to work and learn about OTV. So this is now turned out to be obsolete. Cisco is not at all, popularizing OTV anymore. Make sense? Does it satisfy your question, dear Kumran?
yes, okay. But still, some of the customers still they are using OTV, correct?
Yes. I don't ignore the fact that still some of the customers they are using OTV. We can check when OTV is going to be end of life product and end of support by Cisco. Well, I saw OTV for the last time in the year 2000. That is with regards to my customers in the year 2015. For the past 6 years, I have not seen any of my customers using OTV.
Yeah, yes, correct. The 9Ks don't support OTV anymore.
Yep. Quite an old technology which Cisco is not selling anymore. Okay, and VXLAN is supported by RFC 7348 and 7432 for our MPBGP EVPN deployment. We will see what is this. VXLAN is available on which switches? With regards to Nexus 5K, 7K, and 9K, When it comes to 9K, any model of Nexus 9K supports VXLAN. When it comes to 7K, it becomes more choosy. That is, it says, all right, if you are using 7K, then you need to have F3 line card. And guys, we have discussed about evolution of line card in our Nexus hardware section, right? So 9K, all the models. And when it comes to Nexus 5K, it is available only with 5600 Nexus 5600 switches, not available in the previous model, say 5500, etc. So this is quite an important. Why? Because in our examination, CCIE data center lab examination I'm talking about, Cisco provides an VXLAN on Nexus 5K and Nexus 7K. Now, when we will be doing lab, we will be using Nexus 9K to configure VXLAN. We are provided with Nexus 9K in our lab to configure VXLAN on it. There is slight difference when it comes to configuration, which I will be telling you during the course of our lab understanding, configuration understanding. The difference between difference in configuring VXLAN in Nexus 7K, because Nexus 7K command syntax is slightly different as compared to 5K and the 9K. 5K and 9K configuration has the same command syntax, no difference. All right. Then the further question comes is why VXLAN? Anybody, in case if ask you why VXLAN, you can give a high level answer that VXLAN support multi-tenancy. And definitely, and in interview, if you say VXLAN support multi-tenancy, he's going to ask you what is multi-tenancy. And then when he asks you what is multi-tenancy, tell him, do you know what is AWS? Answer to a question is not a question, but you can ask him that yes, you know what is AWS. What AWS provides is AWS provide a concept called multi-tenancy. AWS, Amazon Web Services, in its public cloud services do not provide ownership of the devices. But AWS do say that in case if you want to avail the co-location, not the co-location is not the right word nowadays, hosting services, that is you want to use certain applications, then for none of your application you need to bother any leakage in terms of difference between the customers. Say he says that all competitive customers can come to me, for example Coke and Pepsi, they are the competitors, they can come to AWS and they will use the same devices, but there will be no communication leakage between them. How it is going to become possible? This is possible with the help of internal technology called VXLAN, where VXLAN has a leverage of providing 2 raised to the power 24 IDs. 2 raised to the power 24, exact number is 16,777,216 IDs, as against VLAN, which provides us 2 raised to the power 12, which is 4096 IDs. So by the virtue of having approximately 17 million IDs, that a service provider can provide easily multi-tenancy. And well, I will be more comfortable to explain you what is multi-tenancy when we will do the lab, because this is a practical concept. So in case if you have the curiosity to know what is multi-tenancy, how it works and all the stuff, then please wait for the lab to come. And further on, if you want to have a more clearer view of multi-tenancy, then please wait for VXLAN topic to get over, because in ACI, application centric infrastructure, what we do is we do use the concept called multi-tenancy. For that, there is a logical understanding which is required. For that, we need to have patience, we need to wait for application-centric infrastructure topic to be started. And that's the reason, after VXLAN, we directly jump over to our ACI. All right. Besides it, VXLAN has so many other attributes, qualities like layer 2 multipathing, loop prevention by the virtue of its connectivity itself, right? There is no scope of having loop. It uses layer 3 ECMP, equal cost multipathing, and guys, whenever the term ECMP comes, then comes a question from me, that is how ECMP is provided. The ECMP using VXLAN is provided, and the answer to which lies in its header. One of the field in the header has an attribute, has a quality of providing equal layer 3 equal cost multipathing, and this is the question I'm putting to you guys right now. Then on in the class, before completing the theory portion, I will give you answer to the question, and indirectly during the course of our theory sessions, I will keep on giving you hint to find the correct answer. Well, this means we are going to discuss the VXLAN header as well. So one of the field, I repeat once again, one of the field in VXLAN header is to be credited for providing the equal cost multipathing, and I told you about multi-tenancy. So with all these beautiful qualities, it is the VXLAN which requires a handsome understanding, a systematic understanding of each and every command. Guys, when we will configure VXLAN, the syntax and each and every individual command is very important and is very sensitive to establish our tunnels. All right. Terminologies. Well, we have already discussed about what is underlay. Underlay is nothing but it is a layer 3 network. That is, when we configure IP addresses on the leaf and the spine switches, and of course layer 3 network needs a routing protocol. Which routing protocol we use nowadays and is recommended is OSPF. So before even establishing the VXLAN tunnel, we need to configure IP addresses, we need to configure OSPF, and please do not forget we need to configure multicast. And when a terminology called multicast comes, guys, in the journey of VXLAN, I will give a pause to our ongoing journey. Why? Because I holistically believe to give one crispy session on the multicast, because VXLAN is incomplete without multicast. So on Monday, we will not be doing and talking about VXLAN. Rather, Monday we will be talking about multicast. There will be a session, a crispy session on multicast with the holistic intention to revise the terminologies and understand those terminologies very well, and of course to know what is RP and its significance. So this means that VXLAN, in order for its implementation, requires our layer 3, that is IP addressing knowledge of routing protocol, OSPF, and of course knowledge of multicast. Multicast, being one of the weakest point among all of us, needs a quick and crispy revision, and that's the reason Monday class will be dedicated on multicast. All right, which will empower us to establish and set up our underlay network. Overlay network types we have already discussed. Beautiful. VXLAN is nothing but it is a technology, overlay technology, and you can say the VXLAN is analogous to 2 raised to the power 24. In case if someone asks you what is VXLAN, give me in one single letter, then you can say VXLAN is 2 raised to the power 24. And then he will simply say, what the heck you're talking about? Then you say 16,777,216. He will say, what the heck is it? You can say that this is approximately 17 million. He'll say, what the heck is it you're talking about? He said, VXLAN has an attribute of providing the VNIDs, which are this much in number, as against VLAN, which provides us IDs which are only 4096 in total number, which is 2 raised to the power 12. This 24 means this VXLAN IDs, it is a 24 bit, and we are going to see where is it in our VXLAN frame format. So we will look at into the anatomy of VXLAN frame format as well to understand significance of certain important bits. That is going to be there in our day 3 class, that is on Tuesday. I'm just giving you a fair idea of our path. VTAP. VTAP may be physical or virtual devices. They are called VTAP by the virtue of configuration. VTAP devices, by the virtue of their configuration, that is when we do configure them, have an interface known as network virtual interface. This is the interface on our VTAP devices from where tunnels are created. So you have a VTAP here, you have a VTAP over here. In order to establish tunnel between these VTAPs devices, what we require an interface, and that interface over here and over here is known as NVE interface or network virtual endpoint interface. This is something new which I didn't tell you earlier, but very important in terms of our configuration. All the VXLAN configuration for establishing tunnel, I will not say all, but significant configuration are done on this interface. Now, there are two similar terminologies, bridge domain and VN segment. You know what? They are same. We use the terminology called bridge domain specifically in terms of configuration, specifically when we are configuring VXLAN on Nexus 7K switches. When we are configuring VXLAN, we don't use the terminology bridge domain for the configuration, and instead we use terminology called VN segment in our Nexus 5K and in Nexus 9K. So you can say that VN segment, what we understood. VN segment is what is a counterpart of VN segment in case of underlay? This is VLAN segment. This is a counterpart. VN segment in case of our overlay, however, VLAN segment in case of our underlay. When we say VN segment, this means we are going to talk about the VNID. This is what we configure. When we say VLAN segment, we just configure VLAN ID. We just focus our attention on VLAN ID configuration. Well, I'm not feeling comfortable because all these theory components, theory definitions could be understood when it comes to the lab. So guys, I'm not trying to convince you to understand it. I'm just trying to make you aware that these are the terminologies. When we will come to the lab, that time again, will discuss about these terminologies. That time, in the moment you have curiosity, you will be able to understand it very well practically, because therein you will be configuring VN segment, you will be configuring NVE interfaces, you will be talking about VTAP and VNIDs, and of course multi-tenancy as well. This is just an introduction of the terminologies. The implementation of the terminologies will be in lab. That's what I want to stress upon. So please don't miss the lab session if you really want to understand VXLAN. Otherwise, VXLAN is incomplete. All right. So, but still, if you have any question, doubt, please feel absolutely free. Let me know how much am I able to deliver you.
G.
Yes, Kumran.
In VXLAN, so can we segregate which is coming under overlay, which is coming under underlay? In this theory, can we segregate or no?
If I give you a quick answer, yes, but I would still like to understand the depth of your question.
Yeah, so that tunnel part, I mean VTAP, tunnel endpoint, and VNID and NVE. Those are we can say overlay, and bridge domain and VN segment, it's coming under underlay. We can say that way. No.
Well, all the terminologies which I have mentioned over here, starting from overlay network, all these terminologies are with regards to overlay only.
Overlay only. Okay, okay.
Yes, I really have to make it look neat and clean. Right. Does it make sense? Yeah, no, it's back to neat and clean. All right, let us go slowly. Underlay, we have discussed, right? So I think it's quite clear about underlay. Yes, forming our underlay is one of the most important. And all right, let me tell you something about the lab examination and something about our lab which we will be providing with. If you go for Cisco CCIE data center lab, Cisco will not ask you to configure the underlay. Cisco will provide you a pre-configured lab on underlay. But since the lab is not a configuration lab, but it is configuration and troubleshooting lab also, Cisco does expect you guys to have the underlay knowledge and will inject some of the faults in the underlay configuration. There is a background noise. May I request the guys to go on mute in case if you are not? All right, thank you. Great response. So same thing we are going to do over here as well, but we are not going to inject the troubleshooting or incomplete configuration. The lab which you are going to get over here, that will be a pre-configured underlay lab, that is IP addresses on interfaces will be configured. The lab will be an open lab. You can look at into the configuration, and I would highly recommend and request you guys, once you will get the lab, please look at into the underlay configuration. And in case if any one of you have, say, EVNG, right, and you want to set up your lab, I will highly recommend you to set up your lab and do the configuration from scratch, from the connectivity to IP addresses configuration to OSPF configuration. So lab that will be provided to you for the purpose of practice, that will be a pre-connected lab and pre-layer 3 configured lab for underlay. Okay. Any
Ashish,
question? Please, yeah.
yeah. Why OSPF, EIGRP, and ISS? Why not the BGP? There is any reason?
Okay. Well, BGP we do use. We do use BGP, but for what? Not for the underlay purpose, but for overlay purpose. And the variant of BGP which we use is called MP BGP. Well, another answer to your question is a question from my side, right? When we say OSPF, EIGRP, right, and ISIS, and if someone asks us to establish difference between these and BGP, then you will simply say these are the IGPs, interior gateway protocols, and BGP is a exterior gateway protocol. But
Yes.
besides this, right, everybody knows about it. But besides this, when we study about BGP, we say BGP is a path vector protocol. Path
Right.
vector protocol. BGP is not predominantly to be called as a routing protocol. That means BGP's responsibility is not to propagate the routes. Guys, some of you may not be in conjunction with this statement of mine, but BGP predominantly is a path vector protocol. BGP predominantly is not a routing protocol. This means that advertising the networks is not mandatory in BGP. It is just based on the requirement in case if we want to propagate certain prefixes. So BGP is not recommended for the purpose of establishing underlay. If you want to use it, then I have never used it. I have never seen it, but you can try it, in which you need to advertise networks explicitly.
Yes.
Does it
Thank you.
answer your question? Okay. So BGP indeed we will be using.
But in sorry to interrupt, in ACI, I mean that in ACI, let's example we have a border leaf switch, and if I want to communicate to the BGP through the external route towards AWS or any of the cloud, let's example we have another location, we don't have that. We have a server and we want to communicate via this communication A into B, and so BGP we can run, right? So that is the possibility area.
Absolutely. And that is called layer 3 out BGP configuration.
Exactly. Yeah. Thank you.
And I will show you the configuration in our ACI lab, both for layer 3 out BGP as well as for layer 3 out OSPF on the border leaf switches. Indeed, you are true. Absolutely correct. Well, good. Please do keep on asking the question and give the statement, because this also helps me to know how much you know and how much more can I give you. All right, terminologies about underlay network. Now I'm sure you're comfortable. Overlay network, I believe it's clear. VXLAN overlay, I believe. VTAP, I hope you now got to know what is a VTAP. VTAP is nothing but it is a device. This device can be a physical device. This device can be a virtual device, or we can call it as a virtual switch. What we will be talking about in terms of our configuration, this one. When it comes to virtual device, this means we are talking about something called NSX. That
The
is
heading is
vSphere.
correct. It's a
Sorry.
VXLAN underlay or it's a overlay. This first topic.
VXLAN is an overlay technology. It's not an underlay, but it requires underlay.
Okay.
VXLAN is a tunneling. Whenever overlay comes, you can say it is analogous to tunnel. Right?
Okay.
All right, good. Vxlan Gateway. quite important, Vxlan Gateway is nothing but our VTAP. And this gateway configuration is very important, and I will be able to comfortably tell you this, what is Vxlan Gateway. And you know what, in Cisco ACI we call it as pervasive gateway. Over here you can call it as any cast gateway. To explain you, to convince you this, I need to move over to the lab. I'm sorry, will not be able to convince you right now about what is the concept of pervasive gateway or any cast gateway as used in VXLAN. VTAP that bridges traffic between VXLAN segments. What is this? Don't know. We'll come to it, because this is a very important configuration in VXLAN. We have discussed about VLAN and VXLAN IDs. 2 raised to the power 12 gives us 4096. So many are reserved for different purposes. Under show VLAN, we can look at into the reserved. Some are usable. In case of VXLAN, it is 2 raised to the power 24. In the books, it is written approximately 17 million, but would appreciate if you guys can learn this figure. Not only learn, but learn to say it is 16,777,216 VNIDs. This is what VXLAN provides. And once again, in lab, everything, VXLAN depends wholly and solely on the lab. Without lab, it is incomplete. My explanation is useless. All right, and VXLAN provides us ECMP. Once again, ECMP terminology comes. So guys, you need to understand what component, right? In Vxlan header, there is a component in Vxlan header which provides ECMP. For that, you need to wait for Vxlan header explanation to come. Terminologies. Vxlan segment. Analogous is our, with this Vxlan segment is also known as VN segment in short. Right? Analogous for underlay is VLAN segment, where we define our VLANs. Here, when we say VXLAN segment, here we define our VN IDs, VXLAN network identifiers. In VLAN segment, what we define our VLAN IDs. VLAN IDs. All right. Why is it important? Because we also do a mapping between them. Why is it important? Because we do need to configure them with regards to our different tenants. Guys, the terminology tenant is a cloud-based terminology. In cloud network setup, we don't call our customers as customers, but we do call them as tenant. Multi-tenancy. VXLAN Gateway, NVE interfaces, we already have discussed about. Bridge domain, this terminology is nothing but terminology to be used in Nexus 7K switches during the course of configuration. This is analogous to our VXLAN segment, right? VN segment, same as that of we discussed. Now, I would like to begin a small story about VXLAN, and then we'll conclude our class after having a handsome look on the Wireshark capture of one of the VXLAN. And in the next class, we will decipher each and every individual field in our Vxlan header. So, Wireshark capture. One sweet capture by Wireshark of communication between two VTAP devices. The very first question which comes over here is, what kind of packet is traversing between two VTAP devices? By seeing this particular capture, can anybody help us to identify what kind of packet is being captured over here? Well, answer to each and every question is right in front of you. An answer to a question which I will keep on asking, that is about
Frame.
ECMP, is also over here. Yes, please.
Frame.
Absolutely correct. This is your ICMP packet, which is being captured. So when you execute a ping, what do you see over here? You get to see a source and a destination. All right, then what? On top of this, there is a IP from a source and a destination. Then what happens? Comes your Ethernet header, a layer 2 header, which is a MAC address, the source MAC address and the destination MAC address. Whenever we execute any traffic, we have the application, we have our source IP, we have our source MAC, we have destination IP, and we have destination MAC. Now, the moment this packet traverses through VXLAN, what happens to this particular traffic? Immediately a Vxlan header comes. Vxlan header has got certain important components inside it, and you can see the VNID, Vxlan ID, which is another important component inside the Vxlan header. Guys, in the next class doesn't mean on Monday, on Tuesday, we are going to look at into the anatomy of Vxlan header, right? The total size of Vxlan header, what are these internal components inside Vxlan header? One important component is the VNID. Okay, so a Vxlan header with so many internal fields, they get added up in front of this packet. Then what? Then another additional header comes. This header is a UDP header with a particular significance. Point to be noted for the UDP header is, I'm sorry, before, is the source port of UDP header, which you do see over here. This source port is a dynamic port. The destination port of the UDP header, which you do see over here, is a static, or we can say it is a reserved port. So UDP header for VXLAN destination port reserved number is 4789. It's a very easy to learn. Begin with 4 and then continuous number 789. Never ever forget. This can constitute to be your interview question and has a very important significance. Where? I will not tell you now. Then, guys, the encapsulation process begins over here, because we need to send this particular traffic onto the tunnel. That is the reason the very first header comes is called VXLAN. Well, I have picked a term for this header called shim. Shim is the terminology which Cisco used in OTV because OTV also adds a shim header, right? We'll come to what is shim. Shim is nothing but it's a washer to join two different pieces together strongly. You will see soon that how this piece is joining two different components strongly together. So, well, in the books, because VXLAN is an industry standard, in the books you will not happen to see the terminology shim for Vxlan header, but yes, you can call this to be as a shim header. Finally, one Ethernet header is added in front of the IP packet, and if we divide this entire VXLAN encapsulation, we can divide it into three parts. This part is our inner, this part is our shim, and this part is our outer. So this outer portion of VXLAN, this is nothing but this gets configured on the NVE interface. This is there in our underlay. So VXLAN acts as just a washer to join strongly the underlay and the outer overlay with a strong washer called Vxlan Header. Now, I would appreciate questions from you. I have put my pen down. If you have any question, please ask. Later on, we will decipher we will look at into the inside story of this VXLAN as well. Hope you remember when you started your journey with CCNA, you must have looked at into internal story of Ethernet header. What are the various components, the fields inside Ethernet header, and then IP header. The same thing we require for VXLAN as well. Now, on to you guys. My explanation for the day is over. Well, I don't believe in just covering the theory classes because it looks theory is more of unidirectional in the nature. And you can make it more interactive, bi-directional by asking the questions. Please, if you have any question. All right, so Bhushan, Kumran, Liaz, Marcos, and there is someone just by the name of New joined us from his mobile. Yes, Marcos.
I'm good.
All right, thank you. And someone, a friend of mine, joined just by the name of New. Any question? Shishagiri, any question? Shakir?
Hi.
Yep.
The thing is, what are the prerequisites to go through this concept? I mean, this is a part of ACI, right?
I will not say this is a part of ACI, but if we know it, it will help you to understand ACI. But VXLAN in itself is a technology. Yes, ACI and VXLAN, they both go hand in hand together. The prerequisite for VXLAN is your handsome understanding of layer 3 technologies, layer 2 and layer 3 technologies both. You should know about routing protocols. You should know about IP addressing and the layer 2 terminologies like what is spanning tree protocol, the L2 addresses and all. and something which is a very weak point of everyone called multicast, which I do understand. So to fill that particular gap, I do cover multicast as a session during VXLAN classes.
Thank you.
Yeah. Shakir, any question from your side?
No, sir.
Richard? All right, thank you. Marcos, any question? All right, Kumran, Bhushan? No? All right then. If no question, then thank you very much. Wish you a great, happy, and rejuvenating weekend. Weekends are indeed very important. They help us to rejuvenate ourselves, and they help us to fill the gaps. And all, thank you very much, guys, and a very good night to you, Richard. Thank you so much for joining from Virginia. Bye-bye,
Thank you.
guys.
Bye-bye.
Thanks, everyone.
Thank you. Thank
Bye.
you all.
Wish you a great day.
Thank you all. Bye. Happy weekends.
Thank you.